Hello, my name is Matt Rabel, and this is a demonstration of how to implement web app security, a Java web app, using Java EE6, largely XML based, also called container managed authentication. What I have here is a fairly simple application. You can see the web XML. It's got a few filters in there, some filter mappings, uses Spring MVC, and allows you to see a number of users and CRUD their behavior. So this is called Ajax Login. It's from a blog post I wrote a couple months back. It shows how to implement Ajax authentication using jQuery, Spring Security, and HTTPS. So what I did is I just stripped out all the security portion of it, and I'm going to show you how to implement web app security using just the standard APIs. So first of all, just to show you what the app contains, it's got a list of users. You can add a new user. We'll call it foo. Password is bar, foo@bar.com. Then they show up in the list. So pretty simple application. The first thing we want to do is secure the user's URL. So anyone that views the list of users has to actually log in. To do this, we're going to add a security constraint to our web XML. You can see here we just give it a simple name, doesn't matter what you name it, a URL pattern of users, secure get and post, and secure it for the role name of administrator. We're going to do basic authentication. We're going to call it Java EE login, which displays when the basic authentication dialog pops up, and then we define the security role. One interesting thing with Java EE is you cannot do anything like this, where you put an asterisk at the end of the URL. The only way that works is if you actually do a slash before it. So that's one of the limitations. You can't do regular expressions or anything of that sort. So now if we save that file, stop our server, restart it, we should get prompted to log in. Wait for the server to start up, and oh look, there's an error. Illegal state exception, no login service. So this is because in our pom.xml, which we're using to run Jetty, we don't have a login service defined. So let's open that up. And right here we'll define a login service. So this is just standard login service, hash login service. We match up the realm name, and then this realm.properties, if we look at that, has our list of usernames and passwords. And with Jetty, you prefix it with MD5 or OBF or obfuscated if you want to encrypt the password or obfuscate it anyway. So now if we stop our server, restart it, this time everything should start up just fine. You might notice here I'm using Jetty 8. The reason for that is I want to use Servlet 3, and that was the best way to do it. So here's Servlet 3. So now if we go back to our browser, load up 8080 and try to log in, we will get prompted. So admin is what that MD5 is, and if we click login, then we'll be logged in successfully. Now the interesting thing here is I have a Logout Link, and if we look at that, it's in my decorator or site mesh, default is what I call it, and it's just a simple logout link which happens to hit a logout controller, which invalidates the session and redirects back to the home page. So if I click that, it doesn't actually log me out. And that's because basic authentication holds on to the session until you close the browser. So you can't really log out. So to make things better, I am going to change it to a form which will allow you to log out. So instead of basic authentication, use form-based authentication. We can take out the realm name, and now that will actually use a JSP page that allows you to log out. You also have to change the auth method to form. Now if we stop and restart, we'll look at that login.jsp page. This is a simple form that goes to JSecurityCheck, which is a URL you need to use, and has a JUsername and a JPassword, which are the required names for Java EE 6 container managed authentication. There is no support for MemberMe, so I could actually remove that and it wouldn't make any difference. Now if we go back to our browser and hit that users page, we will end up at a login screen that we can control the look and feel of. And if we log in, it will complete successfully and we can log out. So now when we try to log in again we're prompted. So we've proven that form-based authentication is a bit better than basic authentication. So now the second thing I want to do is I want to show you how you can force HTTPS for that user's URL. This is done using the user transport or user data constraint and transport guarantee confidential. There's a number of them you can use in here. Confidential, integral, and non-confidential. Basically it means SSL. So now if we stop the app server and restart it, we'll get an error from Jetty that says, hey, there's no SSL configured. So the first thing we want to do is configure its connectors. This configuration here shows you that we've added an SSL connector, and it points to a key store which is needed to actually start the SSL listener. To generate a key store, we use the key tool plugin. This is a Codehouse plugin. You'll see here it generates it in the target directory with a dname, keypass, storepass, and then that's used down here for Jetty to run. So now if we start everything up, you can see the key store is deleted, generates a new one. And then when we hit the user's URL, we will be forced to use HTTPS. So this is one of those things that took me originally quite a while to figure out. You'll see an access denied page, and on Tomcat it always redirects you to HTTPS. Well, with Jetty it doesn't, not with standard Java EE 6 authentication. So you can see here our URL is still 8080. That's why the access is denied. If we change it to 8443, change this to HTTPS, then it prompts us to accept our homegrown certificate and everything works. So this is something that I've noticed on Jetty. On Tomcat it does redirect to the proper port because you configure it by default to do that. So I've shown you how to authenticate your users against a file. Now I'd like to show you how to make those users, put them in a database and talk to that database with Jetty. It's pretty simple. All you have to do is change your login service from using a hash login service to a JDBC one. And we'll delete our old one. We'll keep that same name to match up with our web XML and what the realm name is there. And then this file here, JDBC realm, defines our JDBC driver, the URL, password, and how our tables relate to each other. One nice thing about this definition is it allows us to use a username with a primary key of ID in the user table, and the role table has something similar. If you're using Tomcat, it doesn't allow this same sort of flexibility. You are actually required to have the username and the role name as primary keys in a table that relates to each other. So now if we have that defined, go back to our Ajax login, we need to add a dependency on MySQL. And then we can start our web app. And talk to that database. So that database I have listed here, and you can see there's a username of admin and a password that's encrypted with SHA, and so I'm going to change that to MD5. So if I bring up a terminal window, I have a file in here called Jetty Password, and this generates a Jetty password for me. So if I type in admin, it gives me the MD5 of that. I can copy that, and I can put it into my database as the admin user's password. Update it, go back to my browser, accept the invalid certificate. You can also put this certificate in your JRE libsecurity directory, and that'll get around prompting you each time. So of course now if I click users, I'm prompted to log in, and I can do admin, admin. And I'm logged in. So that's how you talk to a database. Pretty simple. Nice thing is, you notice we didn't have to change our web XML at all. All we did was match up the realm names. This has been a demonstration of Java EE6 security, how you implement it, how you can make it talk to a database. There are some limitations. For instance, you can't figure out exactly why an authentication failed. There's no support for Remember Me. You have to configure your container, whether you want it to be LDAP or JDBC or file-based security, and there's no support for regular expressions. In the next series, I'll show you how to fix some of these issues by using Spring Security. Thanks for listening.